architecture, the loosely coupled or distributed application environment, you have got the same server A, server B, and C. In between, you have got a queue. A queue is basically a buffer, or it is removing the dependency. Okay, so that way, when you have a queue, when component A does its job, it will forward the work to the queue here, and then when controller B has to work, it will take the work from B, because it has to feed component B to work. The same thing continues. When component B done working, it will forward the messages to this queue, and the component C will actually pull the messages from here, so that the dependency between the components, the servers, is removed. Even if the server B fails, server C or component C will continue to receive the messages from queue as long as the queue has some messages in it, so your C can process the messages, right? Well, let me give you an example, and let me tell you what services from Amazon will contribute to this particular distributed application environment. So SWF and SQS are the two components that contribute to a distributed application environment. These two components will help a developer to architect and to develop the applications uh, in Amazon Cloud. Well, like I said, these are the two components, including the CloudFront. These are the three components that are the developer tools. Okay, so let's see an example. How does it look like? So this is an example wherein you've got a website that basically does the image processing. Okay, so users will upload their images, and the images will be processed. Let's say if you upload a JPEG file, the file will be converted into a PNG file, let's say. Or if you upload PSD Photoshop file, the file will be processed and it will be converted into a JPEG format, right? So the idea here is this application, this application will convert your images into something else. Or if you upload a file of 10 MB, it will compress the image file and it will make maybe 1 MB, right? Assume a compression and conversion of images is the functionality of this particular application system. So imageprocessing.com is a URL that we people will be getting, that is the end users, and we will upload our images, images that are sized 10 MB, images that are in PSD format, which is in Photoshop format, and we want those images to be processed and we want them to be converted into the JPEG or compress them into 1 MB file size. So as you upload the file will actually go to an EC2 instance over here. So the role of EC2 instance, there are two components in here, component A, component B. The role of component A is to take the images from the user, upload them into S3 bucket here, okay, and tell component B to process the images. Okay, so the role of component A is to just interact with the users, get the images, and dump them into S3. And the role of component B is to convert them or to compress them and send the result back to component A saying the conversion is done, right? So there are two components, and components have actually are performing their own job. Now, the component A keep talking to the users and receiving the images. As soon as image is received, image is actually uploaded into S3 bucket, and when an image is uploaded to S3 bucket, a message is sent to the queue here. A message is sent to the queue stating, hey, this is the image file and this is stored into so and so bucket. Can you please process this into, this is a PSD file and you need to convert into JPEG. And there is a second request come in that is also stored into S3 bucket, and this time you have to compress it, right? Hey, the original file size is about 15 MB and the user wanted to compress it to about 2 MB or 1.5 MB, right? That's how the message queue will accommodate all the messages in here. Enough. component will B will go here, will take a message one, and it will start process it. Once the processing is done, I mean, it will find, okay, uh, image, the file name called X. It will go and download the file here, and it will compress here. I mean, it will convert here, and it will upload here, saying the conversion or the compression is done, right? And that message is further sent back to the queue, and your component A will take the message, and it will communicate back the user saying, hey, the conversion of the image has been complete. You can download the file in next 24 hours. After that, the file will be automatically deleted. If you ever seen that in the online, most of the website does the same, right? They will help you. I mean, they will help uh, even when you try to convert a Word document into PDF, PDF to Word, any other file extension conversions, you will see, you will receive an email from them stating the conversion has been complete. You can download the file in next 24 hours or 48 hours, after which the file will be deleted. The same functionality in here. Once the conversion is done, the component V will send a message back saying the conversion is done. So the component A will send a email notification to the user saying the conversion has been complete. You can download the file, and this is a URL to access it. Right now, this queue is actually removed the dependency between these two. So the dependency between these two components, that one has to be available while the other is working. For example, if the A fails, right, B can continue to work as long as the queue has some messages in it. Okay, and if your B fails, A can work as long as as long as users have something to upload, or the S3 bucket has got some storage in there. So we know S3 can store unlimited amount of storage, right? A single file being 5 terabytes. Okay, so this is an example wherein you can achieve the distributed application environment. Component B can be in a different location, or component B is actually uh, there is no dependency for component A to be available to process the request, because the message queue is not inside the EC2 instance over here, but the messages are in a distributed and a reliable staging area, maybe a buffer, wherein you can pull the messages from the queue. This is called SQS, simple queue service. Okay, well, we'll talk about SQS and SWF later, but yes, to tell you the difference between the closely, the coupled and decoupled application environments, or the distributed application environments, and the dependency integrated application environments, this is how it looks like. So to move on, like I said, this is a responsibility of a developer to design and to develop such kind of applications, right? To define the roles of component A, and to develop the component A, and to define the roles of component B, and to develop the component B's functionality. And we as the system administrators have to provide whatever he needs. He need a security group, he need an EC2 instance, he need an auto scaling, he need S3 bucket to be created, he need EBS volume, the same components in the B, elastic load balancer that we have to create, and DNS, that is Route 53, that we have to create. So it's a responsibility of the system administrator to facilitate the underlying infrastructure, and it's the responsibility of a developer to design and develop the application code such a way that it is actually a distributed application environment. Okay, that said, let's quickly move on for SQS. Well, like you saw, SQS is a simple queue service. It is fast, reliable, scalable, and fully managed message queuing service. Now I believe you all understand what does it mean by a managed queue service. So it's installed, configured, and managed by them, by AWS, right? We are just using it. So Amazon SQS makes it simple, cost effective to decouple the components of a cloud application. You can use Amazon SQS to transit any volume of data at any level of throughput without losing messages, or messages require other services to be or the other services to be available continuously, right? You can send any volume of data at any level of throughput, and you don't lose any message And importantly, you don't need the other system to be available. Like you saw the component A and B doesn't need A to be available to process the images. Similarly, A doesn't need B to be available to take the request from the users, right? And basically, like I said, SQS is a buffer between the application components. Okay, one receives the data, the other actually process the data, right? And the other thing is it's a buffer, and when your processing server cannot process the work uh, fast enough, okay, even in that situation you can maintain the queue, not just to remove the dependency, but let's say your component A, which is taking the request, is very fast, and component B, which is actually processing the images, is slow. So when a component one is fast, component B is slow, what will happen? The message will overflow, meaning component A cannot maintain a huge buffer, and then you start see the messages will overflow. So to avoid that, you can use SQS, which is actually a queue service, a fully managed, scalable, and reliable queue service, which can store any amount of data similar to S3, right? It can store any volume of data at any level of throughput, and you can store any type of data in the queues. Okay, so even that situation you can use SQS. And SQS ensures that each message uh, delivers at least once, and there can be multiple readers and writers to the same queue. Firstly, uh, there is no uh, message drop as such in SQS. Every single message that comes to the queue will be delivered, no doubt about it, 100%. And it supports multiple readers and writers to the same queue. Okay, so not necessary always you have only one component that is writing and only one component that is reading the messages. You can have multiple components writing and reading the message from the same queue, meaning multiple applications can interact with the same queue. And it doesn't guarantee you there will be no duplicate messages sent to the queue. There will be there will be duplicate messages sent to the queue. However, a message is processed only once. Okay, and SQS service doesn't guarantee the first in first out delivery of the messages. Okay, right, first in first out. So it can be last sent message can be processed first, or first sent message can be processed last. But there is no first in first out guarantee, and there is no guarantee for duplicate messages. However, they guarantee you that a message is delivered at least once, and each message can contain up to 256 KB of text in any format, and it can last 14 days in the queue. A message can be in the queue for 14 days. Well, there is a similar service in Microsoft Azure cloud called Fabrics. Okay, so in fact, Fabrics, Microsoft guarantees the first in first out. It is also similar service um, that is to facilitate the distributed application environments and to facilitate the buffer between the application components, right? Well, this is about your SQS. SQS is a fully managed, scalable, and reliable queuing service, wherein the components can send messages to the queue, and the processing components can read the messages from the queue. To explain this, I wanted to take an example to explain it better. Maybe if you have questions, keep hold with your questions until I complete an example, then we can proceed. Uh, when it comes to the SQS, there are three components that you need to know, or I say three features or components, the terminology I say. So one is message attributes, long polling, and the dead letter queue. Message attributes is about the metadata, right? When a message was sent I mean, the signature, the identifiers of the message. So it's completely about the metadata of the message, right? So the source system or the receiving machine, the application that it belongs to, write out what time that it is sent, how long can it leave in the message queue, or the visibility time starts or not. So these are all the information, the metadata about a message that is sent to the queue. So Message attributes is completely the metadata information about a message. The long polling, well, what happens is it's like uh, this component A, this is a queue, and component B, right? As there is no direct communication between component A and component B, whenever component A sends a message over here, B never knows. B never knows that A sent a message here. So the only way is B continuously polls here. It comes here, checks if there is any message. If there is a message, it just message and process it. That's how it works. So as it never knows if there is a message sent to the queue, B has to continuously come here, take the messages, come here, take the messages. When it come here, if there is no message, it will go back and it will come again. So the long polling is basically is to send, let me, yeah, wait time seconds, right? You can send an argument called wait time seconds, so that when you send a request, I mean, when you actually poll the queue, when you actually go and check the queue, and there is no message in the queue, that's when you can send an argument called wait time in seconds. With that, you can ask it to wait for 20 seconds at the queue itself. When there is no message, you can pass on this argument stating, hey, you wait for 20 seconds in the queue itself. Maybe in that 20 seconds, you can see some more messages coming in, right? So, and then after 20 seconds, it is written. If there is a message will be written to the B and B will process it. So this is the long polling is basically to help the component B to save on some CPU cycles. Okay, so because every time if it every single minute or every multiple times in a minute, if it has to poll the queue, return the results and process them, and if there is no message in the queue and you just have to poll, and then that is additional CPU cost for you, right? The CPU cycles. Instead, you can save them and you can use those CPU cycles for your actual conversion or the processing. So your long polling is basically to send an argument so that it can wait at the queue. And then dead letter queue is basically uh, it is to sideline and isolate the unsuccessful processed messages. This is to find RCA, that why a message is not processed. To understand that, you need to understand which message was actually not processed. Right? To understand that, uh, you have to send on a kind of a parameter or an argument to the queue, and to isolate and to sideline a message which was not actually processed, right? So these are the components or the three features that are part of SQS to understand the message metadata and to pass the wait time and to understand the unsuccessful processed messages. And like I said, this is an example that I wanted to talk about, wherein uh, there are three components: component 1, 2, 3, and these three are actually configured in an application environment where there is a SQS configured. SQS, simple queue service. Well, if you see, component 1 sends message A to the queue. Okay, as soon as component 1 sends message A to the queue, the message is actually sent to the queue, and queue is actually, what is that? It is a scalable, reliable, and fully managed queue service. So you can see here, uh, a message is redundantly distributed across the Amazon SQS servers. You see, so these are all the servers. The message A is actually distributed across the servers just to maintain the redundancy. Okay, and now as soon as the message is sent to the queue, we know that the component 2 will retrieve the messages. So component 2 retrieve the message A from the queue, and the visibility timeout period starts. As soon as you poll a message, a visibility timeout setting of 40 seconds will start. in that 40 seconds of time, this message will not be is not visible actually, so that the other processing system will not take the same message. In component 2, you can have multiple servers that are part of component 2. One server take message A, just to avoid that the other server also takes the message A, there will be a visibility timeout of 40 seconds it starts. Okay, now the component 2 will grab that message. Component 2 is ready to process a message. It retrieves the message from the queue. Message A is written. While the message A is being processed, it remains in the queue and is not written to the subsequently received retrieve request for the duration of the time visibility timeout. Right? And the component 2 process the message A and then deletes it from the queue during the visibility time out itself. Okay, so that once the message processing is complete, it will make sure that it will go and delete the entire queue here, that there is no message lies in the queue. Okay, so basically it's a three-step process. Your component 1 and component 2, when one sends a message, 2 will retrieve it, it will process it. Once the processing is done, it will delete the message. So in that gap of retrieving the message and the processing the message, to make sure that the same message is not written to the subsequent retrieve request, it will just set a timeout period of visibility timeout. In that visibility timeout, the message is not displayed to the subsequent retrieve calls. Once the image processing has been complete, the component 2 will just go there and delete the message from the queue. Right? So yeah, seems Anup have some question to ask.
The one question is which came to my mind, since this is a queue, right? Simple queue service, like any other queuing services. When you get the data, here I saw first limit is limit being 256 KB, right? I think that's quite a bit of data, but there may be sometimes we may need to send messages which is more than 256 kilobytes. In that cases, how do we handle? Is there any workaround for that with SQS? That is the first question.
Well, you're right. It is just a queuing service, like any other service. But here, the capping given is a single message cannot be more than 256 KB. And if you are in a situation that you have to send a data that is more than 256 KB, to my knowledge, because like I said, it's more into the developer. So to my knowledge,
Most,
I don't think.
most likely, I think it should not be that big. In the queue itself should be short and in a reasonable size. I was just thinking out loud, because if at all, I don't think so. Our developer needs to shorten that within the limits, less than 256 kilometers.
Yeah,
right?
that's right. Yeah, what I think is, developer may have to find another way to shorten the message. Otherwise, even we have in our organization, we use this service SQS, but I've never heard from them that they have such challenges with
Yeah, I
SQS.
know.
Yeah.
Okay.
Even I believe it's the 256 is even in Microsoft, it is the same size to my knowledge. They also have a sim when you go to the Fabric, which is a queue service. Even the 256 KB is the message, a single message size. Yeah.
The second question is, retrieving the messages from the queue. Right? You said component A and B, right? B reading the message from the queue and processing it, right?
Right.
And how do we configure that? What message from the queue needs to be processed? That has to be configured, right? Like, there will be IDs in the queue, like job ID 1 or something, right? Job ID 2 or whatever, Q1, Q2. So how does this know any specific queue needs to process, or it will process anything whichever is in the queue?
Yeah, that's more of an application how you write it, right? Let's say if you have a component 1, 2, and 3. So there is a separate queue for communication between 1 and 2, and there is a separate queue for communication between 2 and 3. So that way you can isolate.
Needs to take care of it, right? Okay.
Yeah. Yeah.
And you said once the purging part, you said there's a deletion. The queue itself deletes it. Once you process the queue, after we've been processed, it deletes that entry, the queue.
Right.
So,
the component B itself.
That was my question earlier. How do we purge? Because it will keep growing the queue and the purging. It looks like you explained.
You can. Yeah, component 2 will delete the message. Well, see how how you retrieve the message from the queue is one, how you program your application. Maybe you can say, like you said, the job ID, right? Or you can also filter by something else. Maybe you just can query the message with, if you have a text, something like job ID or something of that sort, you can process it. Mostly, as the queue service is pay as you go, right? Whatever you use, you only have to pay for it. It's not like you have 100 queues, you have to pay for 100. And end of the day, you only have to pay what you consume. So it's better that you always create separate queues for your separate components.
Okay, got it. And one more last one, I don't want to take much time. Any real-time examples of this streaming data with the help of SQS being used? Like, what kind of like, it could be stock ticker symbol or video
Well,
streaming, right? Or those kind of things?
yeah, this is also one of the example where you do image
Oh, yeah,
processing.
image processing, yeah, image processing is one of them, yeah.
Yeah.
Okay, sounds good. Thank you.
Yeah, thank you. Well, then the second one is SWF, the workflow service. This is also one of the components that contribute to the distributed application environments. Well, like I said initially itself, these are the components that are more into the developer profiles. We still do a theoretical discussion here because there can be questions in your certification program, one or two questions. For example, how long a message can last in the queue? It's 14 days. Right, so that way there can be one or two questions coming in this area. To my knowledge, I believe there must be one question coming from SQS, one question coming from SWF, one question coming from the CloudFront. Okay, so that's the reason we are doing. Otherwise, you will not be. I mean, you will not be developing the queue. You will not be retrieving the message from the queue as an administrator. Keep that in mind. So yeah, so SWF is again a component that contributes to the distributed applications. So SWF is a simple workflow service. So when you use SWF, you can implement workers to perform tasks. The workers can run either in the cloud, or it can run on premises, or it can run in another cloud platform. Okay, so the SWF have some terminology in here, some components in here. That is workflows, workflow domains, workflow history, actors, tasks. So it may confuse you, right, as we talk about these different components. But let's see the workflow. Workflow is basically to coordinate and to manage the execution of activities that can be run asynchronously across multiple computing devices, and that can feature both sequential and parallel processing. So workflows is basically a, a job, let's say, okay, an application environment, and that application may be an order processing system. And that order processing system has to talk to different components before it executes the order processing and it delivers the item. But all those components can be part of, let's say, the order processing system have to talk to the portal, wherein it first have to identify if the required item is available in the list or not. I mean, in your godoms or not. The second is the customer address. Can you deliver the item to that particular address or not? And third thing is maybe the payment gateways. That payment gateway is not in your organization. You are maybe leveraging somebody's else's payment gateway. So that is not in your infrastructure. You still have to talk to that payment gateway, right? And you have outsourced the delivery system to somebody, a vendor. Then you have to talk to their system also to execute the order. That way, you have to talk to multiple components. But still, when you configure that in workflow, this workflow will actually uh, can execute a sequential or parallel processing between the devices. Either it can be on premises or off premises or in a different cloud platform as well. And then you have workflow domains. A domain is basically to group the tasks or activities or jobs together that are related to a single particular application. So workflow domain provide a way of scoping AWS SWF resources within your AWS account. You must specify a domain for all components of a workflow, such as workflow type, activity type, etc. It is possible to have one or more workflows in a domain. However, workflows in different domains cannot interact with each other. Like I said, it is to scope your AWS components. Okay, if you, like I said, if you have an order processing system and you have one more application which need the workflow service, you can define the domains so that domain A, domain B, components in domain A can talk to each other in order to execute the work. Well, certainly you don't need components in domain A talk to components in domain B, because that is completely a different application altogether. We don't need the coordination as such. So the technical boundaries are components in a workflow domain can talk to each other, but components in another domain, workflow domain, cannot talk to cannot talk to across uh, workflow domain. Communication is not allowed. That way, when you have to define a scope, you make sure that you put all the components that are part of an application or a job are put together. Okay, and then workflow history is a detailed information about when the workflow was started or a task in the workflow was started, completed, the status, how long does it took to complete the job. So it's all the metadata information about I mean, in fact, including the metadata and the history of the jobs can be found in workflow history. That is to look at, maybe to understand the summary of a workflow, how long it took, or if the status was failed, for what reason it failed. All those information can be found in history. And then actors and tasks. So don't confuse with these two, actors and tasks. One is, actor can be a workflow starter, decider, or activity worker. Okay, so actor can be a starter, which starts your workflow, or it can be a decider. Let's say if the payment is successful or not. If it is successful, then actor will decide, yes, the payment is successful, initiate the delivery. So actor will take such decisions. Whereas task, Amazon, yeah, so task, Amazon SWF provides activity workers and deciders with work assignments. Okay, so your your activity tasks or your lambda functions that you execute, or your decisions that you execute, right? So when an actor take a decision, your task will execute that, right? So I know that this is a bit confusing. To make it more understandable, I try to give you an example here. Okay, so this is a 20-step process. This is the entire life cycle of an SWF workflow. So the workflow domain and the workflow is a generic definition, but yes, workflow domain. So this 20-step process, whatever the components that are involved in, are actually put together into a domain. In this domain, you have workflow starters, workflow deciders, and you have got activities or actors. Okay, so let's see. Your customer is placing an order and you have to complete the order. It's and if this is what the requirement is, the customer starts the order, you have to verify the order, right? It's a different system you have got. You have to complete the payment, it's a different system. And for the shipment, it is a different team that you have. And once the shipment is complete, you have to complete the order, right? So component 1, 2, 3, and 4, there are 4 different components that are involved into this particular requirement, this particular domain, right? This particular domain. Now the workflow has started. Workflow is order processing. Once the workflow is started, it went to SWF, and then a decider has started. So a decider will start, hey, is the customer asking us to process the order? He just added the items into the cart. Okay, if the decider says yes, he did added, I mean, decider says yes, um, I mean, yes, initiate the order processing, the results sent back to workflow, and the workflow will again engage the appropriate activity or a task, right? Once the decider says yes, process the order, the result will go back to workflow again. The workflow will initiate one more task, that is to verify the order, right? So this activity of verifying the order will verify that yes, what items do you have in your cart and can we deliver them? Do we have them available in stock? It verifies, and the result are sent back to workflow. The workflow will obviously ask the decider, hey, this is uh, uh, this is the status that the order verification team have sent us. Should we process the order? Should we process the order? Yes, yes, I could see that the items are available and we can send them to the said address. So you initiate, I mean, the payment process, right? It says, the decider says, yes, start the payment processing. And then the workflow, it again engages another task of the credit card payment, or for that matter, any other payment. Takes care of the payment, and once the payment is done, it sends the result back. The results are forwarded to the decider and it will ask for the shipment. The decider will see if the payment is successful or failed. Obviously, it sees that the payment is successful, so it will say, the decider will say, hey, go ahead and ship the order, right? So it will come here, the shipment workflow activity is actually initiated. It will process the shipment. That way, once the order is actually delivered to the customer, again there will be a decider that says, should we finish the order or not, right? That way you have a system for order verification, you have a system for credit card payment, you have a system for warehouse employees who can receive the order and can process it, and you have a component that actually archives your order processing, and it says, yes, this particular order has been completed, and you just take it off, right? So these four components can be put into a domain because they have to talk to each other, they have to coordinate, and to complete this order processing, you can see that you have a workflow that is engaging different workers and deciders here, right? It is engaging a decider who actually decides and tell what needs to be the next thing. Accordingly, the workflow will engage uh, order verification, credit card payment, and shipment of the orders and the order completion. All right. So this is how your SWF works. Um, so there are a couple of questions in the queue for me. Sorry, in the chat window for me. So can you explain the domains in an AWS environment? Well, domain is again the components that come into the scope of that particular application will fall into that domain. So if your use case is something different from the one that we've discussed here, so all those components need to be put into a domain so that they can communicate to each other, right? If the payment information, if the order processing team doesn't know about the payment information, they cannot process it, right? The workflow cannot forward that information to the order processing team. So the workflow should know uh, what is it. The same way, once the order is shipped, the workflow again need to know what is the status of it, right? That way, um, the components that need to talk to each other are put into a same domain. And the second question was, is it a logical container or object in AWS which represent respects to business requirements?
Venkat, what I want to understand is because you mentioned all these modules, right? In order to process the order, you need to verify, charge a credit card, shipping, record completion, all those, start to end. So we create some kind of logical container or a label object in AWS and put all these modules linked together. I'm trying to understand and visualize what is that exactly domain.
Yeah, it's workflow is actually a logical. It's kind of a queue service. It's a kind of service. You go to the workflow service, you create a workflow. In that workflow, right? It's like your
workflow. I understood. Workflow is good because various processes like Informatica and various other
the same thing.
Workflow, right? To modules are interconnected, sequencing, parallelly, concurrent can be done. I wanted to understand what is domain as such. Domain, is it a logical entity where you group
It is.
all this
It's
message?
just a logical entity.
Okay.
You really don't see anything physical in
Yes,
there, or
fine. Got it. Oh, got it. Thank you.
yeah. Well, there is one more question from Mahinder. Is there a number of messages to a single queue? Well, there is no limit as such. A single message being 256 KB in size, you can have unlimited number of messages in a queue, and you need to pay them on amount of storage that you use from the queue. Right. So yeah, as long as your component one is up and running, you just can keep sending the messages into the queue, and the queue can be as large as you want. But one thing is, a message can last for 14 days in a queue. It cannot be more than 14 days, right? Reason I'm saying 14 days again and again, because when I sit for my exam, it was a question, and the other question was, what is a visibility timeout setting? It's 40 seconds. Right? Keep those things in mind. And finally, the CloudFront. So Amazon CloudFront is a content delivery web service. If you remember, when we talk about the global infrastructure of Amazon, and I told you there is something called edge location to deliver the content. So edge location is actually a physical location wherein they have some sort of network device put in to catch the content locally. So the CloudFront is all about leveraging those edge locations to deliver the content to the users with a faster response and low latency. Okay, so the CloudFront is content delivery web service. It integrates with other AWS cloud services to give developers and business an easy way to distribute the content to users across the world with low latency. Okay, so you as a developer, when you start using the CloudFront distributions, uh, and then it's difficult for us to host the servers in almost every country on the globe. Instead, if you can leverage the CloudFront or the edge locations, which are actually distributed in almost every country in the world, that way people from all those countries, when they try to access your site, the content can be delivered from the edge locations instead of the request is being sent to the server and it is served. Okay, so in what all situations you can use CloudFront is, you can use CloudFront to deliver the entire website content, including the dynamic, static, and the streaming content, or you can also use for interactive content. Okay, so requests for the contents are automatically routed to the nearest edge location. So the content is delivered with the best possible performance to the end users around the globe. Now there are three different components, again part of the CloudFront. One is the distribution, origin, and the cache control. So these are the three components that we need to understand in order to understand how a developer is actually leveraging the cloud front, and how the users are being served from the edge locations. Okay, so the first thing, the distribution. So first we need to create a distribution, right? Our job, the CloudFront starts by creating a distribution. So whenever you create a distribution, it's similar to your okay, we are to discuss EB, Elastic Beanstalk. Okay, whenever you create a CloudFront, it is similar to your S3 bucket name. Okay, it gives you a name similar to this. You have some random number and the alphabets mix of it, and then cloudfront.net. It's similar to a domain name, right? And and to serve the files from this CloudFront, you simply use the distribution domain name in place of your website name, right? So imageprocessing.com is what we said initially. So that request goes to the server and gets the content for you, or that request go to the server and will ask you to upload the content. Okay, so instead of using imageprocessing.com, if you can have something similar to it, which can upload the content. Let's say I'm accessing the site from Hyderabad. Instead of me interacting with a server that is in North Virginia, if I can upload the content into a Chennai edge location, and Amazon find a way to upload that object from Chennai to a North Virginia web server, it's a different thing, right? If I have to upload the content directly to a server that is in North Virginia, and I upload content to a catch location that is in Chennai, it's completely different, right? That way, whenever you create a distribution, it gives you this endpoint. Using this endpoint, you have to develop your application. Whenever user is accessing the content, um, deliver the content from this particular location is what you have to tell it. Okay? And you can use the CloudFront distribution domain name as is, or you can use a user-friendly name. I mean, you can create a user-friendly name in Route 53, an Amazon DNS service. We'll see that how to do later, maybe tomorrow when we talk about Route 53. But yes, you can use it as is. It can be reachable on the internet, or you can create a user-friendly name. And then this is about distribution. To feed the distribution, you need the origins, right, from actual location of the data, actual source of the data. Okay, so when you create a distribution, you must specify the DNS domain name of the origin. The origin can be your S3 bucket, or it can be a EC2 instance from where you get the actual the current version of the data. Okay, so from the origin, your the CloudFront will receive the data. The CloudFront actually stores the data into the edge locations. Now, now you understand that you create a distribution. The distribution is actually a domain name, right, which can be used by the end user, or which can be used by the developer to program the application in a way that whenever a user try to read the data, I mean, the request first be routed to the edge location, check for the current version of the data. If that is not available, then you forward the request uh, to the actual EC2 instance or your website. Right? That logic is taken care by the developer. However, this distribution is actually fed by the origin, that is actually your EC2 instance contributing to the web application, or S3 bucket that is contributing to the web application. Right? Now, you may have a question in your mind that if the use case of CloudFront is to deliver the entire website content, that is dynamic, static, interactive, or even the protected data, which needs your credentials, how can it be done, right? Or let's say today in the morning, some part of my application data is cached into an edge location. Later I've changed the source content. How the edge location get to know that the versions are two different, I mean, these are two different versions, and the edge location do not have the current version? How does it know? Well, that is answered using the cache control. Right? You can control the cache. uh, Either you or your application that you program can control the cache. Okay, so initially, once a request is served from an edge location, objects stay in cache until they expire or evacuated to make some room for more frequently accessed data. Getting me? So when you first request for the data when it is served, it is also stored locally in the edge location. It will continue to be there until uh, until the regular expiry period comes in. It's 24 hours is a regular expiry period. Okay, there is a possibility it may expire before that 24 hours, just to make some more room for more frequently accessed data. Let's say, I mean, the edge location, let's say you buy some 2 GB of edge location space. Okay, in that 2 GB, the more frequently accessed data will store here. That's the normal behavior. Apart from the more frequently accessed data, let's say the first page come in here, some part of the data, of some part of your website come in here, and this is served to a user. And normally within 20 after 24 hours, this particular page will be expired. It's a normal expiry period. Apart from that, if the other users keep accessing some other content from the website, to make some room, this page is actually deleted. This page is deleted. That's the first step. Apart from that, by default, the object expires after 24 hours. Once an object expires, the next uh, requests are again forwarded to the origin. Again forwarded to the origin. and then the content is fetched and stored in the edge location. Optionally, apart from this 24 hours or deleting the object to make more room for the frequently accessed data, apart from this, optionally, you can control how long objects stay in the CloudFront. Okay, to do this, you can use a cache control header to set by your origin server, or you can set a minimum or maximum TTL, time to leave. Using these two parameters, you can control how long an object can stay at edge location. Okay, this is a second option. A third option is you can also remove copies of an object from all CloudFront edge locations at any time by calling an application invalidation program interface. Right, sorry, invalid application program interface. This feature removes the object from every Amazon CloudFront edge location regardless of the expiry period. So the first, the second, that you can control using the cache control header or TTL. The third is you can call this invalidation application program. You can by calling this API, you can delete the content from all edge locations, right? And the best recommended way is instead of, instead of you programmatically calling and deleting it manually, it is always recommended you've uh, you look for the indefinite version of the file instead of invalidation object manually. Instead of you calling that manually or programmatically, it is a best practice to use version identifier. So using the version identifier, you can look if it is a current version or the old version. Whenever it is an old version, when you compare this with the actual version of the application and you find the edge location is using the old version, you just delete it and download the latest version, right? It is all completely the developer who compares your edge location content and the application content and keep shuffling, keep updating the content at the edge location, or manually going there and deleting the content every 24 hours. It's all completely the developer who does it. But the overall idea is to deliver the content of your application to the end user with a faster response. Right? To achieve that, you've got the edge locations, so that you don't have to host your application server in almost all countries of, all cities or all countries of the globe. Okay, and again, it is again depends on what kind of application are you hosting, what kind of audience do you have, how critical is that. So there are many factors, but yes, technically to achieve that faster response, you have CloudFront as a solution, and you can create the distributions and you can have the origins configured to your distributions to feed the data, and the distribution URL can be used in anywhere in your application code to serve the content instead of routing the request directly to the application server. Okay, so that's end of this particular slide, and I have one more, like I said, the SNS and the CloudFront, but there is no practical in this area. However, you can go to the management console, you can find SQS, SWF, and CloudFront, and you can do, you can work with that if at all you are curious to understand. Well, there is a question for me in the chat window from Anup. That is, we have regions and availability zones, right? And where does edge location fit in here? Well, regions and availability zones are the data centers. Okay, the the edge location is actually another physical location. Okay, I believe. Well, you can see here In the global infrastructure, you know the regions and availability zones. Region is a place in the globe, and availability zone is a data center, right? So we know that. But to understand the edge location, edge location is also uh, is uh, is also a physical location. You see, AWS edge network locations. This is also a physical location wherein they have some kind of network equipment that is to connect you to the AWS data centers and to catch the content locally. In India, we have three edge locations. You have Chennai, you have Mumbai, and you have New Delhi. So from India, if anybody is trying to connect to AWS cloud, the request is routed to the nearest edge location. So in my case, from Hyderabad, my connection is made to the Chennai edge location. From Chennai edge location to the AWS data centers, they have fiber optic, dedicated fiber optic network connectivity, so that the data can be transmitted very fastly, because Amazon cannot have a dedicated network connectivity between all end users into the Amazon data centers, right? But they wanted to make their service something unique. They wanted to deliver the content on a high speed, low latency network. So to achieve that, they started developing this edge locations. Edge location is a network location the with the cache capacity, with the buffer capacity. So when a user try to connect to any AWS service or any website that is hosted in Amazon data centers, the request is routed to the nearest edge location. If, let's say, in my country, in India, if there is no edge location, maybe the request is routed to Hong Kong, maybe Singapore or Dubai, wherever you have Singapore, right? So in Asia Pacific, these are the edge locations. In Europe or Middle East countries, these are the edge locations. And in South America and North America, you can see. Okay, so and they are still increasing the number of edge locations. That way, requests are made to the edge location, and from there to the AWS resources. Well, the pricing for CloudFront is how much cache control, I mean, how much cache you are using. Is that 1 GB, 2 GB, 10 GB, 100 GB? So based on the capacity of cache that you use, they will charge you. All right. So the next topic that I have is the SNS, CloudWatch, and Trusted Advisor. So this will be a less of a theory and less of a practical as well. But yes, this is to tell you how can you create a subscription and can subscribe to it, and how you create alarms and can receive the notifications. And Trusted Advisor is basically to audit your environment and to tell you the best practices in terms of the cost optimization, in terms of the security best practices. Okay, so SNS is one thing that I've got, and then overview of CloudWatch, the CloudWatch features, the concepts and terminologies like matrices, namespace, dimensions, timestamp, and the periods. Um, you've got units and statistics, alarms. So these terminologies are again the same for any monitoring tool. If you see the namespace, if you see the units and statistics, timestamps, the period, dimensions, so it's the same for any monitoring tool. The CloudWatch is monitoring tool in Amazon Cloud, but yes, even if you go to a traditional data center level monitoring tool, and if you try to see see the terminology of a monitoring system, it will be the same like your statistics, the performance counters, the alarm definition. It's the same. Okay, and we also see the limit and cost of a CloudWatch alarm, and then we'll talk about the optimizing cloud infrastructure in the name of the Trusted Advisor. So to start with, the SNS. Amazon SNS is a web service for mobile and enterprise messaging that enables you to set up, operate, and send notifications. I can say it is a notification service. It is a managed notification service. It was set up by Amazon, and it is being used by us. SNS is integrated into many AWS services. Okay, we are able to use it to retrieve notifications when an event occurs in our AWS environment. Most importantly, SNS and CloudWatch are integrated together to bring a fully functional monitoring solution to your AWS cloud environment. So SNS consists of two types of clients. One is the publishers and the other is subscribers. Publishers are also called as the producers and subscribers are called as the consumers. Okay, because the publishers will send the message and subscribers will actually subscribe to it and consume it. Okay, and there is something else called a topic. A topic is similar to your distribution list. Okay, a DL in your regular office environment, you have a distribution list, right, wherein multiple users are part of that DL. For example, server team, you have a DL, and the team members that are part of server team will subscribe to the DL, similar to the networking team, storage team, management, HR. So all those teams have a distribution list for them. Similarly, in SNS, a topic is similar to a distribution list, right? If you subscribe to that topic, your email ID, and you will receive email notifications. For example, the CPU utilization alerts is a topic, and if you subscribe to it, to that particular topic, you will keep receiving the messages. Okay, so the components or concepts of your SNS is a topic, a subscription endpoint, and a subscriber. A topic is, like I said, is a DL, distribution list, to whom the message need to be sent to. A subscription endpoint is it is actually a topic. Okay, a subscription endpoint is nothing but a topic. Let's say the CPU alerts, maybe S3 events, maybe put event, get event, delete event, right? So those are all the subscription endpoints where you have a topic registered to it. And a subscriber endpoint is kind of which format the message need to be sent. Should it be in the form of SMS? Should it be in the form of HTTPS request or a JSON document that you're sending in an email or a SQS message to the queue? What kind of message that you need to send is the subscriber endpoint actually defines. Okay, it may be confusing, but when we go to the management console, you will find it easy. Otherwise, this is how it looks like. You have a publisher. It can be a EC2 instance, S3, or any other AWS service which will push the messages. And you have SNS topic, which is a distribution list. It can be your email ID, it can be your friends, it can be your team's email ID. It is that is subscribing to this particular topic. And once you subscribe to this topic, a message can be sent in the form of SMS, email, HTTP request, SQS, or in the Lambda function. It can be in one of the format. But yes, this is how SNS topic look like, or SNS message service looks like, right? Just to conclude this particular topic, SNS is nothing but a notification service. Okay, so the other day we've seen that auto scaling. So you configure an alert at 80%. When a mission is running continuously for 5 minutes at 80%, there must be one more server up and running, right? It should automatically provision one more server. When that event happened, we saw that there was an email sent to me, and I've shown you what is that email is, right? So to receive that kind of notifications, you can create SNS topics and you can subscribe to it. Okay, so we will simulate a situation to receive an email notification when we go to AWS. But otherwise, CloudWatch and SNS are two services that can contribute very closely. I mean, that can integrate very closely to form a fully functional monitoring environment to the cloud. And your CloudWatch. CloudWatch is again a cheap and easy to use centralized monitoring service that provides a variety of features such as alerts, logging, notification, custom addresses, and many more. Okay, so alerts, it'll trigger an action based on an alert. Okay, it will store the logs. By default, a CloudWatch can store logs for 14 days. and notifications, right? It can send you the notification when you configure SNS to it, and then custom matrices. Apart from the default uh, CloudWatch matrices that you have, you can also develop the custom matrices if you are an AWS developer, and you can also, one second guys. Yeah. So the CloudWatch, you understand, it is a monitoring tool. In a traditional environment, in your data center, or you're in your virtualization environment. So when you monitor it, you have the inbuilt monitoring solutions, or you also have third-party monitoring solutions engaged to it. Similarly, in Amazon Cloud, you either can have CloudWatch or the third-party monitoring tools as well. But 99% of the times, CloudWatch is a better solution for your cloud platform, because the CloudWatch just doesn't integrate with EC2. It just doesn't integrate with your S3, but it is integrated with all cloud service offerings, all Amazon Cloud Service offerings, including your VPC, EBS, ELB, auto scaling, RDS, Route 53, whatnot. All cloud services are integrated with CloudWatch. Okay, but if you see in a traditional data center environment, you have a different monitoring tool for servers, different tools for operating system, different for networking, storage, databases. So there are different tools, but here it is a single monitoring tool that is integrated with almost all cloud offerings, and it's easy for you to set up the alarms or set up the monitoring environment. Unlike your traditional environment, infrastructure in the cloud can scale up and scale down dynamically. And uh, when when you have a new EC2 instance launched, it is automatically included into the monitoring solution. You don't have to do anything manually, right? But if it is a traditional data center environment and you deployed a new physical server, what do you have to do? You have to install that monitoring agent into it, and you have to configure those SMTP or SNMP traps, and you go to your monitoring tool and you see if the server is reporting the data into there or not. So it's a lot of manual work. Even when you delete a server, I mean, when you decommission a server, you again have to follow a lot of process of removing the server from the monitoring tool, removing the SNMP traps, going into the server and removing, I mean, uninstalling the agent. So there is a lot of manual efforts involved in it. And if you are actually adding some 100 servers every day and removing another set of 100 servers, and then you need a separate team to handle your monitoring stuff alone, right? When you go to the cloud, adding the servers to the monitoring solution, removing them is all automated. You don't have to worry about it at all. Okay. And the other thing is, the traditional monitoring tools that we use, we have to do the capacity planning. For example, if you have to monitor some 200 servers, when you install the monitoring tool, you have to configure the database for 200 servers and configure server resources. Sorry, yeah, configure the server, the monitoring tool. I mean, where you are installing the monitoring application, that particular server resources also need to be configured accordingly. And tomorrow, when your 200 servers become 400, obviously you have to find a way to scale up the resources of your database, your web server, and your web application server of monitoring solution. But if it is in the cloud, no matter, you can scale down to 1,000 servers in a day, and you can come down to 2 servers in the same day. And the monitoring piece is automatically handled because that is installed and configured by AWS, and you are just using it. And when it comes to the features, it is easy to use, and it dynamically tracks the instances. Of course, the ease of use, that is integration with the other services, or set up, the CloudWatch is set up by Amazon, right? And dynamically tracking the instances. Like I said, adding the instances to the list of monitoring inventory or removing servers from the list of monitoring inventory is automatically done. That is automatically done because that is actually a feature that is part of virtualization. right? If any of you are working in VMware or Hyper-V or any other virtualization platform, you know that whenever you create a mission, that automatically displayed in vCenter server, and that is by default being monitored by the vCenter basic monitoring parameters that you set up. Okay, or if you need, I mean, if you have any additional monitoring tools like vRealize Operations Manager, which is a additional monitoring tool for VMware from VMware, you can find it in there as well. That automatically registers itself. Or wherever you have your vCenter integrated in any other monitoring tool, you will find the newly launched virtual machines are found in the monitoring tool. And when you delete the when you delete the virtual machines, that deregistration of a mission in the inventory is also registered in the monitoring tool, right? The same thing is carry forward to the cloud level. Whenever you launch an EC2 instance or you terminate it, that is automatically tracked in the inventory of the CloudWatch, so that it stop monitoring it, right? And then when it comes to the terminology or the concepts of the CloudWatch, you've got matrices, namespace, dimensions, timestamps, and the period, units, and the statistics. Don't confuse, there is a lot of it, but yes, matrices or metric, right? What when you say database, for you to understand how the database server is functioning, uh, how will you identify? How will you identify that if the database server is doing good, bad, worst? Do I have to add more CPU capacity, memory capacity, disk capacity? How do I know? Well, you have to monitor the matrices. Okay, you have to monitor the matrices. So what is that matrices says? For example, let's say your EC2 instance. EC2 instance have CPU, memory, CPU, network, and disk matrices. Okay, so CPU usage is a matrices. Disk usage is a matrices, right? Database instance CPU utilization is a matrices. That way, a matrices is actually a value that you're monitoring. Okay, each matrices will have a data point with a timestamp associated with that. For example, the CPU utilization is 80% yesterday at 8 a.m. in the morning. Okay, so 80% is a data point that is associated with a timestamp called 10 a.m. Hope you understand it. Similarly, the network latency or disk latency, there was a disk latency, a read latency that was 10 milliseconds yesterday, 8 p.m. IST, right? So a matrices is nothing but a value to monitor. And then namespace. This is proprietary to VMware. Sorry, this is proprietary to AWS actually. Every single service has a name. Okay, it can be like EC2, RDS, S3. All those services have a namespace associated with that. To understand that, I have an URL in here. Okay, the AWS namespaces. If you see EC2, AWS/EC2 is a namespace. If you wanted to monitor EC2, you have to use this particular EC2, this particular namespace. Even when you are making an API call, or when you are developing custom matrices and CloudWatch, you have to use this namespace in order to call the parameters, in order to make the API calls to EC2 instance. Okay, if you wanted to call key management service, this is the namespace. If you wanted to call the relational databases, this is a namespace. Route 53, this is. So that way, these are all the namespaces that are actually for the AWS services. And then you have got dimensions. Dimensions is basically if you wanted to monitor a group of servers. It's not just one or two servers you wanted to monitor. You wanted to monitor a group of servers. Let's say the same image processing solution that you have got. Okay, image processing application that has got an application server, a web server, and a database server. You wanted to monitor all three in a single dashboard. That's when you can use these dimensions, that is maybe a server name and domain. In our example, we can use uh, maybe any tags, right, tags that we are using. right? You can use any combination of the tag, saying maybe server name equals to web db and application server, but the role, when it comes to role, I can mention application server, a role, web server, role database server, right? Wherever server name equals to app db web, and the server role is actually equals to web server, application server, and database server, and application is equals to image processing. So for all three, the application is equals to image processing. So you please monitor them. Okay, so that way in a single dashboard you will be able to monitor all three servers. And then timestamps on the period. Like I said, the very first one, that is a matrices. So when you monitor a matrices, there is a timestamp and a period. Timestamp is normally the CloudWatch data is stamped with UTC or GMT timestamps, time zones. Okay, and the period is yesterday when we configure auto scaling, we said when a server is running at 80% continuously for 5 minutes. So 5 minutes is a period here. That's when you take a action. So period can be as short as 60 seconds, and it can be as large as 86,400 seconds. It's close to a day. So as short as 1 minute, as big as 1 day. Okay. So when you configure an alarm, that's when you use the periods. Okay, and the units are to measure. When I say CPU utilization, is that in percentage, is that in megahertz, is that in gigahertz? When I say disk latency, is that in milliseconds, is that in microseconds? So units are to measure your matrices. Okay, so you can see that the count is for your web requests, the number of web requests, it's count. When it comes to the networking, you can see the data transfer, is that in bytes, kilobytes, megabytes, gigabytes, or terabytes. The same thing when it comes to the disk, bytes per second, kilobytes per second, megabytes per second. The same thing for the CPU, is that in percentage utilization, is that in percentage or in megahertz, gigahertz, or the latency, when you say, is that in milliseconds, microseconds, or in seconds. That way units are the measurement of your matrices. And finally, to talk about an alarm. Okay, so alarm is complete definition about matrices. You can see here a namespace is AWS EC2. You are monitoring this particular service, and matrices that you are monitoring is CPU utilization, and unit is percentage. You are monitoring it in percentage, and the period is 5 minutes. The statistic is average. The threshold is 70%, and dimension is where the name of a server is web server, and the server ID is this. Okay, that's when action is email notification. Now, to completely read out the definition of an alarm is, hey, you please monitor the EC2 service, the CPU average CPU utilization of a EC2 instance, and when the CPU utilization, the average CPU utilization is 70% for 5 minutes on this particular web server, send an email notification, is what the complete alarm definition. Like I said, when you saw these individual concepts in individual slides, you might have confused, but when I put them all together, right, you can understand it very clearly. Namespace is actually the service of AWS, which service you are actually monitoring, and the dimensions are the actual server name. It can be a single server, it can be a group of servers. Here the name is web server, the tag that we configure, and the value is the instance ID. It's the unique number, right? So when you diagrammatically represent the same alarm, this is how it looks like. You have a CloudWatch that is monitoring, and these are the average utilization numbers of the CPU: 12%, 13%, 12.5. That way, these are the CPU average utilization numbers. At some point, it may hit 80% or 70, whatever, as per the alarm definition. So we have configured an alarm that says whenever the CPU utilization hits 80%, send an email notification. Apart from the email notification, you can also ask it to take the auto scaling action, a Lambda function, and you can do a lot here. Okay, so that's about your CloudWatch, and SNS. Uh, Finally, to talk about the cost, by default, the CloudWatch is a free of cost service. It by default it monitors all your services at absolutely free. There is no charge at all. The CloudWatch default behavior is to monitor all the services at a regular interval of 5 minutes. At a regular interval of 5 minutes. That's the normal behavior, and it's free of cost. But if you decide to change the interval as low as 1 minute, that's when they will start charging. I mean, they will start billing you. Okay, it's very simple, guys. By default, the CloudWatch monitoring is free. CloudWatch monitoring is free. So the behavior is they will have 5 minutes of interval to monitor your instances. And if you feel the 5 minutes is like your application cannot leave with the 5 minutes of interval and you need aggressive monitoring option, you can reduce the interval to 1 minute. But then when you reduce it to 1 minute, they will charge you. How much they will charge you? They will charge you close to 3.5 USD per month per instance. For each instance, they will charge you $3.50 per month. This is for your monitoring. Apart from the monitoring, if you wanted to add, 10 matrices and 10 alarms, 1,000 email notifications, and a million API requests are free. Apart from the basic monitoring, 10 matrices, 10 alarms, 1,000 notifications, 1,000 email notifications, and a million API calls are free. And apart from that, if you want more matrices to be monitored, that's when for each additional matrices 0.50 USD, for each additional alarm it's 0.10 USD is charged on a monthly basis. Right, this is the billing information about your CloudWatch. By default it is free unless you do any changes to the CloudWatch monitoring. It is free, but when you reduce the time frequency to 1 minute, they will charge you. And when you start monitoring the 11th matrices for an instance and 11th alarm for an instance, they will charge you 50 cents and 10 cents respectively. And the limitations of the CloudWatch is the data that is monitored is stored for 2 weeks, after which the data is deleted, the first in first out. Okay, and the maximum period of a value that you can specify is complete day. Like I said, 1 minute is being the minimum, 1 day is being the maximum. This is the frequency. This is the interval. You can create up to 5,000 alarms for AWS account, with each alarm support up to 5 actions. It can be send email notifications, trigger a Lambda function to execute something else, or auto scaling event. That way you can have up to 5 different actions and 5,000 alarms in the entire AWS account. It's not the region wise, it's the entire AWS account. And finally, the trusted advisor. Well, a trusted advisor is actually not available in the free accounts. Do you remember when you created the AWS account, you have chosen the basic support plan, okay, and you also have a business and the enterprise support. So when you go for the basic support plan, trusted advisor is not part of it. Okay, so keeping that aside, the role of trusted advisor is basically to monitor your AWS account and to give you the cost optimization recommendations and the security best practices recommendations. Okay, so as you know that the trusted advisor is actually implemented in almost all AWS environments. So let's say there are 1,000 customers who have used the trusted advisor. So trusted advisor have the database, the best practices, how these 1,000 customers have implemented the best practices for cost, for fault tolerance, for high availability, and for security. So using that knowledge base, a trusted advisor will give you the recommendations. Hey, you have this kind of environment. So for this, maybe you can use this kind of solution so that you can optimize the cost, so that you can improve the security, right? So that's how the security, the trusted advisor works. As you know that AWS have lakhs and lakhs of customers today, and trusted advisor have got uh, it has got such kind of database which is actually evolved over a period of time, and today it has got very matured. Uh, it can give you very mature decisions so that you definitely get benefit of the implementations with respect to the cost, with respect to the high availability, fault tolerance, with respect to the security configurations, right? Let's quickly get on to the labs and show you how SNS management console looks like, create the SNS topics, and then get onto the CloudWatch monitoring and see. Well, as you see on the screen, let's go to SNS now. Simple notification service. Here, if you see, there's one topic that was already created, and there are 5 subscription to it. So, a reason I've created a topic is because I've set up a billing notification. Okay, whenever my billing crosses some $10, I need to get a notification. Is what the billing alarm that's configured. Okay, so let's go to the dashboard here, and I say create a topic, and the topic name is uh, let's say CPU alerts. I wanted to create a topic called CPU alerts, and I want all my server team, that is server administrator team, receive these notifications. Okay, so create a topic, and this topic is created, and to this topic I have to create the subscription. Subscription is nothing but the email IDs. So email, that's this is my email ID. I say create subscription. The moment I create myself, create a subscription, it says pending confirmation. I similarly can have more number of email IDs added to it. That's the reason I said topic is similar to the distribution list. A topic is the CPU alerts. To this topic, I already have my email ID subscribed. That way, all your team members can subscribe to this. First thing. Now, it is asking for the pending confirmation, right? It just doesn't start send you email notifications because you give an email ID here. Instead, you have to subscribe to it. So let me open my email ID, my inbox. You see, it's about 0 minutes back. You choose to subscribe to this topic, that is CPU alerts. To confirm this subscription, click this link. So once I click on confirmation, subscription confirmed. You have subscribed to, you have subscribed to Kurela Venkat at gmail.com to a topic called CPU alerts. Now if I go back here, I refresh it, you see this is confirmed. Okay, that way you just go to the topic and you just keep creating the topics. Maybe for S3 events, I say S3 when you create S3, an object in S3. Right, you can certainly use this topic to send. So I've got a notification. I mean, I've got another email here. You see S3 notification, subscribe, right? And you can have topics created for. You can have topics created for RDS, VPC, Route 53. It's like you just keep creating the topics, and respective team members can subscribe to that topic. Understand? Now, how these topics are used to send notification is you have to integrate this with the AWS CloudWatch. Okay, so let me open CloudWatch. So this is how a dashboard looks like, and these are all the alarms that I set up earlier, which the EC2 instances no longer exist. That's the reason you can find them. Yeah, I've just deleted them all. So if I go to the CloudWatch, you see there is one alarm. I mean, one dashboard that I've created is the billing. So you can see there is a red line. Whenever my billing is about $10, send me an email notification and show that in the dashboard over here. Currently, it is close to $5 is what my billing is. My AWS account billing is. Okay. So similarly, you can create more number of alarms here. And to browse the matrices, let me launch an EC2 instance and show you. Well, you see this monitoring. It says enable CloudWatch detail monitoring. As I said, it's the detailed monitoring. In introduction, maybe what are the two different levels of monitoring that is available? Two type of monitoring that is available. One is the basic monitoring with 5 minutes of interval. The other is a detailed monitoring with 1 minute of interval. When you go for 1 minute, that is detailed monitoring, the additional charges apply. Okay, so when I enable this, the additional billing will be on my account. Okay, add storage. Now the instance got deployed. Okay, so to monitor this instance, you just go to the monitoring tab over here, and you can see the CloudWatch matrices. You see, as it shows as if the basic monitoring is on, and it is allowing you to enable the detailed monitoring. However, we set that check mark on, right, to enable the detailed monitoring. Maybe allow until this EC2 instance comes up online. Yeah, you see now the detailed monitoring is on, and disable the detailed monitoring is what it is asking for. Okay, so let it run for a couple of minutes. We'll come back here, and let me go back to the CloudWatch. Right, for you to browse the matrices. Okay, the matrices are nothing but, like I said, the CPU utilization, network utilization, the latency, and all that stuff is called the matrices. You can go to matrices, and the matrices are grouped here. You can go to EBS category, watch them. You can go to billing category, see there are 12 matrices. Elastic Bean Stack, RDS, S3, SNS. That way, whatever the service that you engage, matrices related to those services will be populated here. Right? These, don't think that only these many number of matrices are available. There are many more a lot more number of matrices are available, but those are displayed here based on the service that you engage. For example, EC2 service I wanted to monitor. You wanted to monitor by auto scaling group, by EC2 instances all across, or per EC2 instance. Per EC2 instance, let's say. Which instance you wanted to monitor. So these are all kind of deleted instances. I do not have 6 CC. One second, guys. You see, the instance ID here is 70C615. If I go to CloudWatch, that instance is yet to populate here in the CloudWatch. That is yet to populate here. Okay, so and then let me also deploy one more instance, because so this time I'm not enabling detail monitoring here. I'll enable it in the EC2 management console. Right, so it at least take 5 minutes to take the monitoring effective. So now you can see it just says basic monitoring, and it is asking us to enable the detail monitoring. Right, so it really doesn't matter how many times I refresh it, but still it allows you to enable it, because we did not enable the detail monitoring. So I say enable detail monitoring. Enable detail monitoring for your instance to get the matrices with 1 minute frequency. Are you sure you wanted to enable this? Additional charges may apply. Say yes, enable. Close. Okay, now both the instances are being monitored. It's C411, C615. Okay, so there you can actually see, let's say if this is an instance that you wanted to monitor CPU utilization, you just can select that particular matrices. It get added to the graph here. You see the disk IOPS and the CPU utilization is what we are monitoring. I just take it off, the CPU utilization. That way you can add the matrices to the graph, and you can match them with interval of 1 hour, 3 hours, 12 hours, 1 day, 3 day, 1 week. It can be a custom date and time that you wanted to monitor. It's completely up to you. Okay, and then when I go to the dashboard here, currently the CloudWatch CPU utilization is a dashboard that I've created in the past, and that's no longer exist here. Okay, so I just can delete it, and then you can add one more weight. So the weight is basically to yeah, you see now it has come. C615. Okay, so create a weight. Now if I'm in a dashboard, I don't have to go to the matrices, monitor it all. I've created a weight here, and it certainly whenever I come to the CloudWatch, to the dashboard, I can see that there is a weight that is created, and I can see the CPU utilization of so and so server. If I wanted to compare more number of servers, I can come edit it. I can edit it. I can add the CPU utilization of one more EC2 instance as well. Okay, it's what C615. Certainly, I can add the Linux machine CPU utilization as well. I can say update. Right, as we just deploy the EC2 instances, it will take at least 5 minutes to load the data, to populate the data into the CloudWatch weights here. But otherwise, in a single dashboard, you can see in a single weight, we are comparing the CPU utilization of both Windows and Linux machine. Maybe in a real-time scenario, like I said, it can be a database, web, and the application server, and you can see what's happening with which server of your solution. That way, it will be easy for you to understand what's happening with your application stack, the entire stack of application. Right? That's how you create a weight. Now, for you, how you create an alarm is you can go to alarms here, create an alarm, and let's say you wanted to create a billing alarm, and the total estimated charge is what you wanted to create. Right? You can configure this in your account as well, so that you will get an idea. Right? So it's available in USD. Whenever the billing is, let's say, greater than $1, you can see that here what's happening. If you wanted to receive an alert when there is a 5 USD of billing on you, you can certainly configure it. So you can configure multiple alerts. One is at maybe $1, the other is $2, $3. So that way, if there is a possibility that you may miss one alarm but not the other. Let me call it as a billing notification to $5 USD. Okay, set an alarm status. You see the notification list. Do you see these things that we have created? SNS topics, billing notification, CPU alert, S3 events, right? That way, you need to create a topic here, and that topic will be populated here in the notification list. So I already have the billing notification created, to which Kurela.Venkat is subscribed to it. Okay, and you know that there can be 5 actions configured to an alarm. This is action number 1. You can have one more notification added. You can have auto scaling configured. It's completely up to you. Okay, and this is an alarm definition. Looks like. Right, and you can create an alarm. You can have an auto scaling configured. I mean, if there is already auto scaling group created, you know, right, how to create a group. So you just can take an action to provision one more instance, or completely up to you how you wanted to define your alarm. But my alarm is the current alarm definition that I have to notify me when the billing is $10. Okay, and action is send notification to billing. Send a topic called billing notification, to which Kurela.Venkat is actually subscribed to it. Namespace is this. All right, so that's how you create alarms. And the other option is go to a service that you wanted to engage. Go to a service that you wanted to monitor, and to that service, let's say if you wanted to create an alarm for your CPU utilization. Okay, you see there is no alarm configured. You can say create an alarm, and this is CPU alerts, and average CPU utilization is more than, let's say, 50% for at least one consecutive period of 5 minutes or 1 minute. You will only find this 1 minute when you have the detailed monitoring enabled. Okay, and then the CPU utilization, let's say 50% is the alarm definition that I have, and I create an alarm. Close. Okay, now whenever the CPU utilization is 50%, it will send a notification to my email ID. Apart from the notification, I can also ask it to stop this instance or terminate this instance, reboot this instance. It's completely up to you, right? Apart from this, you can also run the Lambda functions I mean, a piece of code can be sent to execute. That code can ask, I mean, that code again can execute a variety of things. It can clear the queue, um, it can clear the buffer, or it can provision one more EC2 instance, or it can terminate the existing one. I mean, it's again your wish how you wanted to write that small code. And Lambda is a kind of a platform as a service. You just can trigger a piece of code that can send to Lambda, and then Lambda can execute that piece of code, and you only pay for the number of times that you execute the code. That's the beauty of Lambda. Otherwise, Lambda is just a platform as a service offering. Okay, but that will allow you to run the piece of code that you want. And the beauty is you only pay for the number of times that you run the code. If you only run a code once in a year, you only pay for once. If you run maybe 4 times a day, you pay 4 times a day. It's completely up to you. Okay, so I just take it off, save, close. And we know right how to simulate some CPU load onto it. I just can take a putty session, and I can install the Struts utility so that I can send some CPU hops onto it, and then I can easily make the EC2 instance to hit. Let's say this is an instance description here. I'm taking the IP address of the instance. This is a server that we are connecting to. So all your Red Hat based commands will work here in Amazon Linux. You can see the minimum interval period is 1 minute. Yesterday you have seen that it was at 5 minutes. CPU, maybe I can send some 20 hops. Timeout is, let's say, 300 seconds, I say. So when I send this 20 hops of CPU load, it can cause the EC2 instance at least to spike 80-90%. The moment it hits the 50%, as per the definition of the alarm that we have here, 50%, it must send an email notification to a topic that we have configured here, that is CPU alerts. Okay, so let it send. It's enough. It just started spiking up. It's 2% now. Within a minute, it will go all the way to 60-70%. And you see the comparison of both EC2 Windows and Linux machines. The Windows machine is actually running at a higher CPU utilization, because we know the Windows, it takes a lot of processors and it's more of a GUI based. So the average CPU utilization lies between 5 to 10%. You know that the alarm turns into red now. It takes a while to populate, but here when I come, when I just refresh this console, yeah, you see it turned into red now, meaning alarm state. It hit all the way to 100%. Let me see if I've received any email notification. You see, it's 0 minutes ago. You have received this email because Amazon CloudWatch alarm, that is CPU utilization 50% in US East North Virginia, enter into alarm state. And the other thing is, guys, the alarms that we configure are specific to the region, right? They are specific to the region. So the threshold crossed one data point, that is 93.5, was greater than or equals to 50%. Date and time when the alarm has entered. Right? So that way, the SNS topic that you have created, that is CPU alerts, and whoever have subscribed to this topic have received that email. Me, I have received it. And the alarm enter into alarm status. You can see the alarm definition over here, what to do. Okay. So when I go to EC2 management console, see from 93 to further, it went to 100%. So that's how you create a dashboard. That's how you create an alert. That's how you create an SNS topic and you integrate with your CloudWatch. So any questions, guys? Any questions? Okay, then practice your CloudWatch. Just try to deploy a very simple server and try to configure alarms and see. And tomorrow I'll see you with Route 53 topics, which is your DNS service in the cloud.